Good evening, students. Welcome to today's session. Hope you all have attended the assessment. So, today's topic is linked list. In the previous session, also, you were discussing about linked list. So, in last session, you would have got an idea of how you should approach a singly linked list in C++. So, to give a slight recap, a linked list is a linear data structure where elements called nodes are linked together using pointers. So, what is the difference between arrays and linked list? Unlike arrays, linked lists do not store data in contiguous memory locations. Instead, each node contains a data part and one or more pointers that reference the next node in the sequence. Okay, so basically, this structure will allow us to insert and delete in an efficient way. So there are several types of linked lists. Basically, the major types are singly linked list, doubly linked list, and circular linked list. So what is a singly linked list? In singly linked list, each node contains a data and a pointer to the next node. All right. So basically, in a structure, in this data structure, it contains two parts. Okay, so basically, a structure in linked list consists of two parts. What are all the two parts? That one part is the data field and another part is the next field, which is nothing but this stores the memory location of the next node that is being attached to it. Okay, so this is how singly linked list works. Then what is a doubly linked list? A doubly linked list is nothing but it is a form of singly linked list. But a difference is that instead of containing only one pointer pointing to the next node, in doubly linked list, it consists of data, a pointer to the next node, and a pointer to the previous node as well. So, what is the advantage of doubly linked list over singly linked list is that the doubly linked list allows traversal in both forward and backward directions. Okay, there's another type of linked list known as circular linked list. So, what is a circular linked list? It is similar to a singly linked list, but the last node's pointer points back to the first node, forming a circle. That is the only difference. So this can also be doubly circular in where the first node's previous pointer points to the last node and the last node's next pointer points to the first node, which means in singular linked list, I mean in circular linked list, this again divides into two parts, I mean two types. What are those? A normal circular linked list and a doubly circular linked list. The only difference is that the last node is attached to the first one. That's why it is named as circular linked list. Okay. Hope you all know the basics of linked list. So yesterday, I hope we discussed about a singly linked list problem. And today, if you have attended the assessment, you would have known that we discussed, the assessment is about a doubly linked list. Okay. So let us proceed in solving that sum. Okay. So what is the today's problem? Given a sorted doubly linked list of positive distinct elements, the task is to find pairs in a doubly linked list whose sum is equal to the given value. Okay. So first of all, let us understand the problem statement. A set of integers will be provided, and all those integers will be in a sorted way without any duplicates. That's why they use the term distinct. Okay, this is what input is. Now, what should we find? We should find pairs whose sum is equal to target, which means that we will be getting two inputs, that is the set of integers as well as the target sum, for which we need to identify pairs. Okay. So to understand the problem statement clearly, let us look into this input. Here we can see that the input is 7. 7 is nothing but the number of elements in the doubly linked list. And the second input is the node values to be inserted into the doubly linked list. And third input is the target sum, for which we are going to identify the pair. Okay, so by looking into the output, it is very clear that since the target sum is 7, the pairs 6, 1 and 5, 2 sums up to 7. So our target solution is to find and print these pairs. Okay. So now let us proceed in problem solving. First of all, we have to understand the basic. Okay. So let us begin with how the node structure is created. For that, I already have a structure called node. Okay. Structure called node. Now this structure is going to hold me all the three values. What are all the three values? Int data and node star next and the another pointer called node star previous. Okay. So it is mandatory that we should not leave this pointers uninitialized. Then it will lead to wild pointers, which may crash the program. So as soon as we create a pointer, we must initialize it. Okay. So how we are going to initialize means using a pointer. Okay. Node. It is going to take the input data as input. Okay. Now this value will be now data will be initialized to the value, and next will be initialized to null pointer, as well as previous will be initialized to null pointer as well. All right. So here we constructed three components and a constructor that is going to initialize a given node with a given value. Okay. What is going to be our next step means, okay, first if we see from this main function, we can see that initially we have initialized the head node to null. Okay, and we have taken 3 inputs, and using for loop I have inserted all these elements into a doubly linked list. Once insertion is completed, we are finding the pairs with a given sum. For that purpose, now we saw how a structure is created for a doubly linked list, and here input is ready, and we have to insert these elements into a doubly linked list. Am I right? So for that purpose, I am using a function called insert. See, insert. So this function is going to insert a new node at the end of the doubly linked list. If you want to, like if the question specifies to add in the beginning of the linked list, we can modify this insert function. Okay. Okay. How insertion is happening? First of all, as we can see that this head reference and the input data, like the element is taken as parameters within this function. Okay. What I'm going to do, what is going to be our first step means our approach is we will be creating a node for the input data, which is X. Okay. What is going to be my next step? It will check if there is a head node or not. Check head node or not. If not, I'm going to make this input X value as head reference. Okay. I'll repeat once again. How, sorry, I'm writing it in the other function. First, the head reference and the uh, element to be inserted are passed as parameters into this function. What is going to be our approach means first we have to create a node for this input data. Okay. And the next step is we're going to check if there is a head node present in this linked list or not. If it is not there, we are going to make this data as head node. If head node is present, what is going to be our step? Insert data at end by traversing. Okay. So this is going to be our 3 major steps. Okay, let's follow the first step now. Now I have to create a new node for the incoming new data. So new node star, new node is equal to new node of data. Okay, now I have created a new node. What is my next step? I have to see whether if there is any head node present or not. For that purpose, what I'm going to see means if there is no head. I'm going to make this new node created as head node. So head is going to be my new node and return. Okay. Now 2 steps are followed. Then the third step is if the head node is present, I'll be inserting this data at the end of the linked list by traversing the elements one by one. For that purpose, I am going to create a temporary node called temp as usual. Initially, this temp pointer will be pointing to the head. Okay. Now, using a while loop, I am going to traverse this temp pointer at the end of the linked list. Okay. So, while temp of next, I am going to move this temp pointer to the very end of the linked list. Okay. So, at the end of this loop, what happens is that, let's say there are the 4 elements present. At the end of this loop, temp pointer will be pointing to 3. Why? Because that's how the traversal is happening. Now, what is going to be my next step means temp of next. Sorry, actually, at the end of this loop, the temp pointer will be at 4. Now, let's say I want to insert a data called 5. Now, what happens? At the end of 4, I have to insert this 5, which means temp of next is going to be my new node. And new node of previous has become temp. Okay, so this is how insertion is happens. Now coming to the main part of the code, which is to find pairs with a given sum. Okay, so what approach I am going to use means, first of all, I'll do the initialization. I'll be starting with 2 pointers, namely left and right, which is initialized to head of the list, and the right pointer is initialized to the last node of the list. The next, what I'm going to do means I'll traverse the list. Okay. How I'm going to traverse means, first I'll calculate the sum of values pointed by left and right. If it is equal means I'll be printing. Okay. Or else what I'm going to do means, after printing, what I'm going to do means I'll move this right and left pointers to one step ahead, which means at first, see, let's say, okay, now left pointer will be pointing to 1 and right pointer will be pointing to 10. Okay, now let's say our target sum is 11. Now what happens? The sum of values in left and right are 11 is equal. Now, if this condition satisfies, what I have to do, I'll move this left and right pointer to inwards, which means that now left will be moved to 2 and right will be moved to 7. Okay. If the sum is less than x, I'll be moving the left pointer to the next node. If the sum is greater, like once I add the left and right nodes values, if the sum is greater than x means I'll be moving the right pointer to the previous node. Okay. Now I'll be continuing this process until the two pointers meet each other. Okay. Now let us proceed with the code. First, every time we deal with linked list, we have to check if there is any element present or not. Okay, we have to check if it is empty or not. For that purpose, I am using this part. Okay, if there is no elements present, it will just as such return. Okay, now as I told previously, I need 2 pointers. Am I right? So node star left and node star right. Okay, but initially I have to initialize these left and right pointers to the leftmost and the rightmost. Am I right? So leftmost I have initialized to head. Now what about the rightmost? I have to traverse, right? Before that, I'm initializing a right pointer to the head as well. Now I'll be using a while loop. And I'll be finding the last node now. Okay. Now at the end of this loop, what happens? The right pointer is assigned to the last node. All right. Okay. Now I'm using a Boolean variable called found, which is going to be initialized to false. Okay. Now, what I'm going to do, I'm going to traverse the left and right pointers. So for that purpose, what I'm doing means I'll be using a while loop. While left is not equal to right, which means that we have to traverse these pointers until they meet. Okay. While left is not equal to right and left of previous is not equal to right. Okay, which means that the left pointer should be in the left side of the linked list and the right pointer should be in the right side of the linked list. As if we check, like if left of previous is right, which means that this right pointer has gone ahead of the left pointer, which is the end point. Okay, we should not allow that. Okay, we'll be checking for these two conditions. Okay, now what I need to find the sum of the left and right pointers. Summed for left of data plus right of data. Okay. What I am going to do, I have to check if the sum is equal to the target sum or not, right? So if sum is equal to x, what happens now? Found will be changed to true and I have to print it. Okay. Okay, in the same format as our expected output, we'll just include these brackets. Okay. Now, what we discussed previously, if we find the target sum, we have to move both the pointers, right? So what I'm doing, left is going to be moved inwards. So left is equal to left of next. And right will be moved to the previous node, right? So right equal to right of previous. Else, we checked for one more condition. Where if the sum is less than x, what happens now? I'll be moving only the left pointer. If this condition also fails, it goes to the else loop where right pointer is alone moved inwards. So for inwards, I'll be using this previous pointer, and for the left pointer, I'll be using next. Okay. So at the end of this loop, we will be identifying all the pairs that sum up to the given sum called x. Okay. So we have to also check, like what if there are no pairs? To track that only, I have used this Boolean value called found. Okay. If found is still false, we can conclude that no pairs. Okay. Now to check this, let us just print it. Okay. So this will not be necessary, I guess. Okay. Let us try to run the code. Okay. There is an error in the line 59. Okay. Yes. As you can see that for this given input, the target sum is 7, for which it has identified the pairs 6, 1 and 5, 2. Okay. So this can be solved in both singly linked list and circular linked list as well. Okay, like based on the problem statement. If you understand the approach, like what we have done in this find pair sum function, you will be able to solve few other problems as well. Okay, and there is another point to remember that this logic where we are moving the left and right pointers to inverts will be applicable only for a sorted array. Okay, in case if you are encountering an unsorted array, what you can do is first you can just sort it and you can follow this idea. Okay, like instead of thinking of a new logic for that unsorted array of elements, what you can do is you can simply sort the elements first and you can follow this approach. Okay, so this will be helpful for a normal array sum as well, not alone linked list. Whatever the concept it can be, if you understand this logic, like this works only for a sorted array, you can make use of this logic. Okay, there are few more practice problems that are similar to this, like I have listed down based on the placement point of view. Okay, like today's assessment question is like one of the mostly asked question in placements. Okay, so there are similar questions to that question is we have to find the triplet in a doubly linked list whose sum is equal to a given value x. Like instead of finding two values, here we are summing three values. Okay, so the second question is find pairs in an array whose sum is equal to a given value x. Today we discussed about linked list. You can use the same logic for array as well. Check if a doubly linked list is a palindrome or not. What I'm going to do for that purpose, I'll be first reversing the given node. Okay, once I reversed it, I will be comparing the original node's value to the reversed node's value. If they are similar, we can conclude that it is a palindrome. So for reversing a doubly linked list, it is quite simple. Why? Because we are just going to reverse the pointers. Okay, there will be two pointers, right? Previous and next. We'll just exchange those pointers. Instead of moving the entire node to the reversed manner, we will be changing the pointers of the previous and next values only. Okay, so merge two sorted doubly linked list into a one sorted linked list. And another question is remove duplicates from a sorted doubly linked list. So what happens when removing nodes is needed means we'll just change the pointer. Okay, so in linked list we need not worry about like space is left as such. Like what we have to remember is, let's say there are elements called 1, 2, and 3. 1 is pointed to 2 and 2 is pointed to 3. If you want to delete this element 2, you'll just detach that element 2 from 1 and 3 and you will connect the node from 1 to 3. Now in this way 2 is left unattached, right? Now what happens? It simply gets destroyed. So that's how removing happens in a linked list. And reverse a doubly linked list. Like if you understand how palindrome is done, you will be able to solve this problem as well. And find the intersection and sort a doubly linked list, rotate a doubly linked list by a node, or split a doubly linked list into two halves. So you can take a screenshot of these problems and work out. Why? Because not alone in doubly linked list, these problems are so common in arrays as well and singly linked list. Okay, so please practice these set of questions to understand more about linked lists. Okay, thank you for joining today's session, students. Good night.